Gradient descent in Python. In Python, gradient descent is an optimization algorithm that helps to find the local minimum of a function. It is widely used in machine learning and deep learning to minimize a cost or loss function by iteratively updating parameters in the direction opposite to the gradient. It serves as the backbone for training models, enabling them to minimize error and improve accuracy. What is gradient descent? Gradient descent is a method used to find the lowest point of a mathematical function. In machine learning, it helps reduce errors by making small changes to the model's parameters, always moving in the opposite direction of the steepest slope. The algorithm calculates the slope, or derivative, of the function and updates the parameters step by step until it reaches a minimum value. This approach can be used with any function that can be differentiated. Those professionals who are working in data science, artificial intelligence, or software development, understanding gradient descent and its implementation in Python libraries is crucial for building strong and efficient models. Mathematical formula. The following formula is used to apply this concept. X, new, equals X, old, minus alpha dot operator f, X. Here, X, new, is the current value of the variable. Alpha is the learning rate. X, old, is the derivative of the function. Implementation. This expression is a tool used to find the lowest possible value of the function f. A equals a squared plus 4a plus 4. In programming terms, you can think of this as an optimization problem where you are looking for the absolute minimum output. Understanding how to calculate this point is a foundational concept for building machine learning algorithms. We can achieve it by following these steps. Step 1. Importing module. Step 2. Minimize the function. Step 3. Apply derivative. Step 4. Define the gradient descent function. Step 1. Importing module. First, it needs to import the NumPy and Matplotlib modules in our program. For that, see the example below. Importing NumPy and Matplotlib modules. Import NumPy as np import Matplotlib. Pyplot as plt. Step 2. Minimize the function. The function below demonstrates how to implement the minimum function to minimize the function. Defining a minimization function def f. A. Return a asterisk 2 plus 4 asterisk a plus 4. Step 3. Apply derivative. The following function demonstrates how to apply a derivative to a function. Apply the derivative in this function def df. A. Return 2 asterisk a plus 4. Step 4. Define the gradient descent function. In this step, we will create the gradient descent function. Follow the example below to write the function in your code. Define gradient descent function def gradient descent, sp, lr, iters, a equals sp for I in range. Iters, updating step a equals lrdf. A, print, f, iteration number, I plus 1, a equals, a. Point 4 f, f, a, equals, f, a. Point 4 f, return a. Define variables sp equals 0 lr equals 0.2 iters equals 13. Print minimum gradient descent min equals gradient descent, sp, lr, iters, print, f, n local minimum occurs at a equals, min. Point 4 f, f, a, equals, f, min, point 4 f. Here, sp indicates the starting point. LR indicates the learning rate. Iters indicates the iterations. Output. Iteration number 1. A equals 0.8000. F. A. Equals 1.4400. Iteration number 2. A equals 1.2800. F. A. Equals 0.5184. Iteration number 3. A equals 1.5680. F. A. Equals 0.1866. Iteration number 4. A equals 1.7408. F. A. Equals 0.0672. Iteration number 5. A equals 1.8445. F. A. Equals 0.0242. Iteration number 6. A equals 1.9067. F. A. Equals 0.0087. Iteration number 7. A equals 1.9440. F. A. Equals 0.0031. Iteration number 8. A equals 1.9664. F. A. Equals 0.0011. Iteration number 9. A equals 1.9798. F. A. Equals 0.0004. Iteration number 10. A equals 1.9879. F. A. Equals 0.0001. Iteration number 11. A equals 1.9927. F. A. Equals 0.0001. Iteration number 12. A equals 1.9956. F. A. Equals 0.0000. Iteration number 13. A equals 1.9974. F. A. Equals 0.0000. Local minimum occurs at A equals 1.9974. F. A. Equals 0.0000. Explanation. The above example demonstrates how to find the minimum gradient descent starting point 0 with a learning rate of 0.2 and a number of iterations of 13. That's all for this video. Join our WhatsApp channel and developer community channel on WhatsApp to get knowledge about latest technology and stay updated in community channel. Links in the description. Don't forget to like my videos and subscribe my channel.